Hello and welcome back to this last section. In this section, we'll talk about launching Docker containers in AWS. We will take a look at AWS' own container running service called ECS, and we will see how to use it. We'll see how to launch and cluster the containers and sum up with pros and cons of using ECS. In this first video, we will take a quick look at what EC2 Container Service is. We will take a look at what ECS and ECR are. We'll see what is a task definition, what is a task, and what is a service. When you first start with ECS, you will be given an option to go through a wizard that will create a cluster and a repository for you and create all the resources that you need to run your Docker container. While I encourage you to go through that wizard and create all the resources, it doesn't really explain what all the things that it creates are and may actually create some confusion. So let's take a look at all the pieces that make up EC2 Container Service. First of all, Container Service inside AWS is made of two parts. One of them is Amazon ECS, which allows you to create your clusters and your tasks. The other one is ECR, EC2 Container Registry, which allows you to create repositories for your Docker images. You can use both of those services independently. You don't have to use the repositories with the container service and vice versa, but it is easier to use both of them. ECR, the container repository, allows you to create repositories for your Docker images. It may be quite similar to Docker Hub. You simply build your Docker image and push it into the repository. You can always see the push commands inside the console. First, you always have to run the get login command from AWS CLI that will return a Docker login command that you have to execute in order to authenticate against the repository. You then simply build your container, tag it using the repository URL and Docker image tag, and simply push it. If you run all those commands, your Docker image will appear in your repository. That's all there really is to ECR. It's simply a repository where you can push and pull your images. If we go into the container service, there's a couple of terms that are used within the container service that can be quite confusing at first. So let's take a look at what they mean. The most basic building block of your containers inside ECS is what's called a task definition. Task, which is defined by the task definition, is a group of one or more containers which share the same constraint and things like the network mode or IAM role. Task definitions can be defined either from the console or from the JSON file. Let's take a look at how it looks inside the console. You always have to name your task definition. You don't have to specify a role if your containers don't require any specific IAM permissions. You can choose the networking mode, which is similar to what you can do in Docker. You can add constraints to your task definition, on which we'll talk in one of the next videos. And the most important bits, you add containers to your task definition. To add a container, you have to provide the repository URL and the container name. The image URL can either be an ECR repository or any other Docker repository. The only other thing that you have to specify is the memory limit for the container. You can also specify a lot of options that you should be familiar with from Docker files. Things like mapping your port from your container to your host. But also, if you'd like to override some of your settings like the entry point or command. A setting that is specific for ECS is marking a container as essential. If the container within a task is marked as essential, if that container fails, the whole task will be considered failed and will be restarted. This is useful if you have multiple containers running within a task, but not all of them are, as the name suggests, essential to the actual task that is being performed. If the container is not marked as essential, if it fails, the task will continue to run and will not be restarted. One of the interesting features in task definition specific to AWS is the log configuration. By default, Docker logs are outputted to your container output. In ECS, you can choose what to do with that output. You can, for example, send them to different services. One of those services is AWS Logs. If you choose this configuration, you can specify the logs groups and region for the CloudWatch logs, where the logs from your container should be placed. This will automatically get the logs from your container and upload them to CloudWatch. One downside, even if you log into the EC2 instance running the container and try to get the logs by running Docker logs, they won't be available. Let's check out how a very simple task definition looks like after it's been created. Each task definition can have multiple revisions. You would usually create a new revision for the task definition when you have a new version of one of the containers within the task. The task definitions can be very simple. For example, this task definition simply launches a single container with its default settings. Once you create a task definition, you can use it to launch a task. A task is nothing else than simply a running version of what has been defined within the task definition. To run the task, you can simply choose the Run Task option. You will also notice an option to run and create a service. The difference between the task and a service is usually quite confusing. A task is simply a running version of your task definition, so it is simply running your containers. You can think of tasks as one-off executions of your task definition. If you're interested in having long-running tasks or autoscaling to add more tasks, for example, depending on traffic, you can create a service. To run a task, you can simply select the option here and specify how many tasks you would like to run. This is useful if you want to run a one-off task to perform a specific action. Simply running the task doesn't offer you an option to do any autoscaling or assign the task to a load balancer. If you want those options, you have to create a service. Now, a service is basically a group of tasks that allows you to run multiple tasks of the same type, but also handles things like deployment of the tasks, launching new tasks when old fails, and assigning the task to the load balancing. I have an example service running here. This is running a simple task which simply has an Apache web server serving a default page. As you can see, this service is assigned to a load balancer. I am using an application load balancer here, but you can also use a classic load balancer. It has deployment options, which defines how many tasks should always be running and how many new tasks can be created during a deployment. You can also specify a strategy for placement and constraints. Because a service can be running multiple tasks of the same type, you can see your list of tasks over here. You can go into every task, see its status, which instance it's running on, and its task definition.